Hello friends, welcome back to virtual session on Python based data science. In today's session, we'll be discussing about exception handling. To understand exception handling, firstly, we need to understand what is exception. Exceptions can be termed as runtime logical bug. There is a difference between syntax errors and the exception. Syntax errors means if there is syntactually any error done by a programmer, then that termed as a like syntax error. Now syntax error can be captured and can be trapped by compiler itself. It will not allow the program to compile successfully. But if your code is error free, syntax there is no syntax errors, and if there is logical bugs occurred during the execution, then your code is going to terminate abruptly, and this abrupt termination will cause a severe damage to the system. You may lose the code, you may lose the entire database connectivity, or if you are dealing with the projects, severe damage can be occurred to the system and the code because it's a unhandled exception. You may lose the connectivity with the server forever and many more things. So to avoid these troubles occurred while during the execution, a good programmer will make a practice of handling all these runtime bugs, handling these exceptions, and how to handle these exceptions. That comes under the category of good programming and practice. So let us discuss this all stuff related to the exception handling, starting from the basics. What is exception means, and in Python, what mechanisms we are going to follow to handle these all the exceptions. First of all, let us define what is exception. An exception is an event, it's an action which occurs during the execution of a program that disturb the normal flow of the program's instructions. Means if you had written certain instructions and that all instructions are error free, it means there is no syntax errors over there, and then when you set for the execution, if there is any logical bug occurred, then that time your program gets terminated abruptly, and that is actually called as that logical bug. You can't avoid it because you already coded and code was like error free, and then the logical bugs occurred. Now we'll be discussing by examples what exactly mean by the logical bug. So if that logical bug occurs, for example, if you want to understand what is logical bug means, as we know that denominator never be zero. So if you write expression c equals to a by b, and during the executions the value of b as a denominator becomes 0, so division is not possible. But syntactually, c equals to a by b is a correct syntax. So during the time of compilation, it get compiled, but at the time of execution, because of the value of denominator 0, it throw the exceptions and it will abruptly terminate the code, and that abrupt terminations, as I already told you, will cause a severe damage to the system. So logical bugs bound to occur or raised in case of program executions. So how to handle them, how to trap them, how we can exception handling will convert that normal termination to the to convert that abrupt termination to the normal terminations. Means your code will warn the user, because many times what happened that, like, if the exceptions remain unhandled, then you'll get a message something went wrong, and you and the system will be abruptly terminated. So in such situations, programmer will not come to know what exactly happened and how to debug that all the bugs. So the better idea is go with the exception handling. Now, types of exceptions, as I said about the errors. Errors means, okay, sometimes syntactually, okay, sometimes we forgot to assign the block over block at the code. There is maybe the indentations errors, there may be some syntax errors over there, so that all comes under the category of errors. And next is unchecked expressions, means without using exception handling, if you just write the code, right, there is no syntax and errors, and though the logical bug raise the exception, that is called as unchecked exception or unhandled exceptions. When one has to understand that unhandled exceptions will cause a severe damage to the systems, because as I said, your syntax errors, semantic errors can be handled by compiler itself. It will not allow the program to compile, but unhandled exceptions which will execute the code and then abruptly terminate, that is called as unhandled exceptions. And hence, by using proper exception handling code and techniques, we can check the exceptions, and if that exceptions are raised, it can be well captured, and that abnormal terminations which was supposed to occur at the time of unhandled exceptions will be it will warn the user that this is the error and this is the line number where that exceptions or logical bug occurred, and it will terminate the code like normally, and hence the severe damage to the systems can be avoided. Here is the actual block of exception handling. What the code which you think that there might be some bugs may occur at doing the executions, that entire code you need to put in the try block. This is called the exceptions block. Means if any runtime bugs occurred, means like one can say that we are testing this entire code prior to the executions. If a system is given to you and we don't know like what may happen to these systems at the time of runtime, but if something worst happen with the systems, then obvious it's a lot of damage and loss will be occurred. So to avoid that, test that system. So if any logical bugs occurred, then it will raise the exceptions, your compiler will raise that exceptions, and then that exceptions, that runtime environment, instead of saying compiler, that runtime environment will run because compiler's role is to compile the code over there, and then there is a role of your interpreter or your runtime environment. That runtime environment will raise that exceptions, and if your code have means like whichever the exceptions you have, whether it's a specific exceptions you specify over there or with any general exceptions, it can be catch over this code will be executed. And if there is no any exception, logical exceptions also not there, then this else block will be performed, right? And finally, means anyhow whether it is having an exceptions or it don't have any exceptions, then that time this finally block is going to execute, right? So this is what standard way of writing exception handling code in Python. You have a try block where you can test the code, you have an exception block, except block, where you can handle the exceptions or where you can capture the exceptions, and that code will be executed when the exceptions will be raised. You have else block, it means if there is no exceptions occurs, then else block is going to perform, and the finally block which is going to perform anyway without or because like this else block is actually when the exceptions is raised but not that the exceptions are not defined over there. So in that case else block will perform, but finally block will perform without raising the exceptions and with raising the exceptions as well. So here we discuss about, we have a try block, we have a try block, we have a except block, and we have a finally block over there. Try block is going to test your code, except block will handle that exceptions, and then finally block is going to execute code regardless the like your exceptions raised or not. So this is what concept called as exception handling the runtime logical bugs if any occurred in the systems. That is what exception handling means. And the motive of exception handling is a good programming practice, and the second, that to avoid that abnormal termination to the normal termination by prompting the user that this is the logical bug occurred. So in Python exceptions, in today's sessions, I'm going to discuss about exceptions versus syntax errors, because many times we will find difficulty to understand the difference between syntax errors and the exceptions over here. So let us understand this, what exactly the difference between the exceptions and the syntax error. Then we'll be discussing about the raising an exceptions, how we can raise an exception. Raise an exception means if this is the situation, then raise these particular exceptions. As I said, if you have a code, I'll be discussing these all the things with examples. If you have a code, and then if your compiler, your runtime environment will find the exceptions and raise it. But if you want to raise your own exceptions, like at any situations, then you can use the raise keyword over there. Then there is assertion exceptions we're going to discuss, and then we have a try except block of handling exceptions. We have a else clause, and you have a finally clause over here. Let us discuss firstly the difference between the syntax errors and the semantic errors. Here in this case, if you write print 0 by 0, so obviously here what I write, one extra parenthesis I'm using, and this is the syntax error. There is no error in the syntax error in the 0 by 0, but like because of we are having an extra closing parenthesis, okay, it is a syntax error over here. But the same thing, if you try without syntax error, then it become exceptions. This is where we need to understand what exactly the difference between the syntax error and the exception. Syntax errors means if there is any grammatical error, if there is any type error, just like here in this case we had an extra closing parameter, so that become a syntax error. And when the syntax is correct, but now the next logical error is there, and that logical error is you cannot divide any number by 0, and that is called as zero divide error, or division or modulo by 0. So that zero division error will be occur here. So this is the difference between your syntax and the exception. Now let us firstly understand programmatically. Okay, so for that reasons I'll go to the command prompt, and let's load a Python compiler. Okay, here it is, and then if I type print in the bracket 0 by 0 and add an extra argument, extra closing parameter. Deliberately I am trying to like they develop a syntax exception, syntax error. So here it is, it's a syntax error because the syntax, the command which you had given to the Python compiler is wrong. But if your command is correct, 0 by 0, here there is no syntax error, there is no extra like closing parameter, then closing parenthesis, then now it is a 0 divided by, it's called an exceptions. Now exceptions means there is no syntax error, but there is a logical error. Logical error means you cannot divide. Right now we are deliberately putting that 0 by 0, but let us understand you have an expression of a c equals to a by b, where you don't know what the values of a and b are there right now. So during the executions, if the value of b after processing it becomes 0, so denominator 0, error may occur at the time of runtime, and then it will develop an exceptions called as zero division error. So hope you understand the main concept of the difference between syntax and semantic errors, as well as the exception, right? So syntax means where the syntactical error over there, and the exceptions means runtime logical bugs where syntax are correct, but the logical bugs occurred in that execution environment. Now let's go to the desktop and the Visual Studio Code, where we can test the various exceptions code, and then we have a Python test, and I'm having a folder called as exceptions. Exceptions. Okay, and then load the VS Code. So firstly, let us here it is. As we just studied that while handling the exceptions, okay, you have to write the try block, means whichever the code or whatever the code you want to test, I want to test it whether it have any runtime logical bugs or not. So I'll put it in the try block, right? So print x, here I'm writing a code as print x. As you know that print x, there is no syntax error, you can print any value of variable, but here in this case the value of x is not defined. So that is not the problem of a compiler, right? It's a runtime logical bug. So here you define the exception, that is called the name error. Name error is predefined exceptions, means if any name, any variable, okay, is not defined, right, is not defined, that then it is a name error will be occurred, and it will print variable x is not defined, right? So, and apart from that, if any, because here in this case name error will occur because x is not defined, but if x is defined, let's say x equal to 5, which is defined, so obviously that time this name error will not raised, but maybe some different exception will be raised, then that will be handled by this except clause. Something else went wrong, right? Here in this case I'm deliberately trying to develop an exceptions that is called as name error exceptions. Guys, name error is a predefined exception in case of Python. So just to demonstrate to you how the try block, except block will work, and then how to trap and exceptions which is predefined, in this case it's a name error exceptions over here. So just run it. Here it is, variable x is not defined, means print x, and it raised the exceptions called as name error, and it directly come to this block and it execute this block, variable x is not defined, right? So now here if there is no other exceptions, then you can even able to write the else block, right? Print this is else block, means if any means if there all the exceptions are not available or not raised, okay, that time it will go to the else block over here, and then we have a finally, right? Means at any situation, okay, whether the exceptions raised or exception not raised, this finally block is going to execute. Okay, let's try it now. So obviously it is going to show variable x is not defined, and then directly it will come to the finally block and it perform the finally block over here, right? But let us understand, if you just define x equals to 5, now x is defined now. Now here in this case, okay, this name error will not occur, this exception also not raised, else block is not going because there is no exceptions over here, so obviously it will print a finally block. Let's try this. Yes, it is, this is a else block, okay, the value of x is 5, right? So it will not having any name error as well as any other errors over there, so it will perform the else block. This is the else block, and it will perform the finally block over here. So here this is the normal way of dealing with the exceptions. So here you need to okay, indentation, okay, fine. So here you need to deliberately need to generate an exceptions, and then name exceptions will be generated over here. Okay, so now let us say the next one is let's try to generate the divide by 0. Okay, if any number you try to divide by 0, here if x is equal to 0, if x may have any other values, and if you try for 12 by x, obviously there is no divide by 0 exceptions, so it will print the else block, something else went wrong, and finally it will print the value of x, right? So let us try it. So it will say something else went wrong, because reason is why your code is abruptly terminated, because something else, there is no division of zero division error, it will something else might be wrong, and this is the final value of x. But if you try to make a value of x as a 0, here in this case it will test the expression 12 by 0, and it will raise the exceptions called as it. Now it will raise the exceptions means your runtime exceptions. You are not deliberately raising the exceptions. Here in this case your runtime environment is raising an exceptions, and then it will be cached by the it will be trapped by the exception block, and here in this case you will get the answer divide by 0 exceptions, and then finally it will print the obviously this exceptions is handled, and then it will come to the finally block over here. So here it is, divided by 0 exceptions, and then value of x is 0, right? So now here in this case we will depend on the runtime environment to test that code available in the try block, and if there is any exceptions, then it will be thrown to the exception handling block, right? But can we able to manually raise certain exceptions? So answer is yes. There are two techniques available, that is raise and assertion technique. So by using that raise and assertion technique, we can able to conditionally raise the exceptions. Let's discuss this. So firstly we'll go with the raise block. Here in this case x is a -1. Now if there is a condition, if x less than 0, if raise, because here if there is no any kind of exceptions are there, but if I think that okay, if the value of x is less than 0, then raise exception, these raise exceptions, sorry, no number below 0 number are not allowed, right? So here I'm trying to deliberately raise an exception. Okay, it is not raised by the by the runtime environment, it is raised by me. If there is a condition, if x less than 0, raise this exception, right? So let's try this. Here it is, sorry, no numbers below 0, right? This it raised the exceptions. So but if the value of x is 5, it means it will not like this condition is not not true. So here in this case, okay, it will not raise any exceptions, and it will perform, okay, it will print value of x, right? Likewise, let us try this. Here it is, value of x is 5. There is no exception over here because the condition is invalid in this case. You can even able to print the value of x like this, instead of comma and x, you give a f, and here you can write value of, in the parenthesis you can specify the variable. This is also another expressions to print the value of any variable. Here it is, the value of x is 5. Now if it is here in this case -1, then the exceptions will be raised, right? And then here it is, sorry, no numbers below 0. So as there is no finally block, so this statement is not going to execute, it will directly through the exceptions and terminate the code over here, right? Okay, so you hope you understand how to raise. Now raise is a keyword, okay, which is going to raise any specific exceptions. Means you as a programmer, I'm writing a condition, I'm setting a condition. If this is the situations, then there is this exception. Then in the next case, here the value of x is hello, right? And if not type x is integer, means I'm checking the type of x is, and if the type of x, now in last sessions we discussed about type function is going to return me the type of that, what type of data that variable holds. So now here in this case we assign the string value over here. So if not x type is integer, it is not integer type, so raise the only integers are allowed, right? So obviously here in this case X is a string type of data, so it will raise an exceptions, only integers are allowed. Let's test it. Type error, only integers are allowed, right? Because type error is a exceptions raised over here. But if X holds the integer value, then this exceptions will not be raised, because this condition is become invalid, and hence it will print the value of X. All right, here it is, value of X. Here we do write like this, F, yeah, the value of X like this. Yeah, value of X is 5. But if it is you assign the string type of data, then it will generate an exception, it will raise an exceptions, and it will print the message only integers are allowed, like this, type error. So here in this manner we can set a condition to raise the exceptions and handle them, right? Now the next is assertion. As I said, there are two ways by which conditionally user can set the conditions to raise the exceptions. First one is raise, and second in this case assert. I equal to 3. The syntax of I in case of raise, you cannot write the conditions. Okay, you have to write the condition and then raise. But here in can with the assert function, you can have the condition assert the condition and then comma the message, right? Message raised by the exceptions. Assert I less than 5, value of I is less than 5, right? And then you can less than 5 over there, and then you can print the value of I. But here in this case, okay, let us run this thing. So it will print yeah, if I less than 5, okay, value of I is less than 5. Just what I is 3. Assert I less than 5, value of I is less than 5. And if you write the okay, means like if you write the 12, then it will throw the exceptions, because this condition is not valid now. Here it is, assertion expression value of I is less than, it should be less than 5. Means if it is less than 5, it's a valid thing, it will not raise the expressions. But if this expression you have written is invalid, then it will throw the exception over here. Now here in this case I is 12, and assert I less than 5 means the value of I should be less than 5, then only exception will not be raised. But if the I is 12 and like I less than 5, this condition is not valid, then it will throw the exceptions over here. Right? Here it is, assertion exceptions, value of I is less than 5, right? So what we understand till now, that while conditionally raising an exceptions, there are two ways. One is raise and assert. In case of raise, we need to write the condition and then use a keyword called as raise, and in case of assertions, we can even able to put the directly conditions there, and if the condition is valid, then it will not raise the exceptions, but if condition is invalid, then raise the exceptions. We are discussing about exception handlings, and what we discussed up till now, that exception handling is a logical technique by which user can write a better code okay, to handle the runtime exceptions. If you not handle the runtime exceptions, now here in this case, the errors and all things, okay, three type of exceptions will be there: errors, unhandled exceptions, and the check exceptions. If you keep your code having certain errors, then obviously your compile errors means your syntax and semantic errors will be checked by the compilers only and will not allow to run the code. But if your code is error free, there is no any syntax and semantic errors, and then if it generates the runtime logical bug, then it's an abrupt termination of the code, and hence it will cause a severe damage to the systems. So it has to be it has to be captured, and for that reason, okay, we have a coding block called as try, except, else, finally. Now try block will test the code, except block will that all the handled exceptions, okay, can be processed, and else block means if there is no exceptions handled, and then there is a else block. Otherwise, finally, it is going to execute without or with exceptions. So this is the better programming techniques by which we can handle the logical bugs or the exceptions in case of Python. If you not learn the programming practice of exception handling, then your code become you can execute the code, but if any runtime logical bugs occur, it will generate the severe damage. It will cause a severe damage to the system. You may lose the code, and everything will be worst thing can be happen. To avoid all the stuffs, exception handling plays a very vital role. Guys, again, I'm sharing these all the codes which I'm tested in these demonstrative sessions in the comment sections. You can go through that and practice it, how we can develop a better exception handling coding over there. Thank you and all the best.